Hello and welcome. My name is Daniel Sanchez, and today we're going to be talking about the weather derivative hedge product that I worked on in my internship with Munich Reinsurance. Before we get into that, I want to give a little bit of background about myself. I'm part of the loudest and proudest Texas Aggie fighting class of 21, where I'm going to be an economics major, as well as I am part of Trip Group 11. This has been my first internship since I joined the TRIP program. A little bit about the company. Munich Reinsurance is exactly what it sounds like. It is a reinsurance business that is a huge multinational with very large exposure all over the world, that they have this saying that's not if, but how. And this really resonated with me because as weather insurance and insurance in general, there will always be a solution. It is just a matter of using intelligence and statistics or whatever it is to find that solution. And that is something that resonated with me at the beginning, and I still hold that dear to me now. A brief outline of what we're going to talk about in this presentation. I'm going to start off by giving an introduction to weather, followed by a brief introduction to US power markets, followed by some data analysis about the product, and finally, a holistic reflection about my experiences. So first and foremost, weather. Weather is everywhere, but we really don't think about it because it is much bigger than ourselves. We often find ourselves powerless in the larger scheme of things, but in fact, there are things you can do. For instance, ever since 1980, there has been approximately 4.2 trillion worth of damage in catastrophes, and this can be hurricanes, hail, wildfires, earthquakes, tsunamis, or whatever it may be. And that is a staggering number, and it is only expected to get worse before it gets any better. Additionally, abnormalities in weather such as excess heat or cold, as well as precipitation or the lack thereof, are extreme factors that can impact economic activity. There's this quote by the EPA that states, "Scientific studies indicate that extreme weather events such as heat waves and large storms are likely to become more frequent and more intense with human-induced climate change." Associated with that, there is this infographic by The Economist that shows the uneven distribution of weather across the United States. And as you can see, there is a disproportionate burden across the South, mostly Texas, Arizona, and Florida. And this is given to extreme weather as well as the progressive heating. Given that it is already significantly hot in the South, if it continues to heat, this will affect agriculture and tourism, whereas places more north, such as North Dakota and Washington, will actually have more favorable conditions. Even Alaska will be able to be more inhabited, so they seek to benefit. But all in all, the net result of this is declined GDP within the United States. So how do you solve this problem? Well, there are really two ways to go about it, and there is the solution of neglect and protect. In the protecting category, you can retrofit your business or household to be protected against weather and just more efficient. However, this is a very microeconomic approach because it's very hard and not realistic for it to be applied to every single individual or entity. However, you have weather reinsurance, which is a more holistic approach because it can cover large players and small players within the whole economy, and it can mitigate risk significantly. On contrast, you can go the negligence route, and this is essentially you just pay for the damage or whatever happens, but this is highly risky as well as a high degree of uncertainty. The one benefit to this is very low upfront cost, but you pay for that in other uncertainties. So weather reinsurance can be used for everybody, but for the most part, it's going to be towards commercial businesses and industrial systems that really have large exposure to weather. These can be utilities or instances such as some commercial retailers that are significantly impacted economically by weather. Additionally, there can be clients that seek these products because they have an inflated balance sheet and they seek to mitigate risk by offloading this balance. Going into power, it is important to know that the US power is composed of independent system operators. And for the sake of this deal, we'll mostly be working in the Northeast. And this is going to include ISOs such as PJM, New York ISO, and New England ISO. So a bit of a briefer, what is an ISO? An ISO essentially forecasts and schedules generation to make sure that there is sufficient power and backup power. Additionally, RTOs are regional transmission organizations, which also help in balancing this by making sure there is enough generation and load and actually executing these types of problems. And they create significant synergies just by creating reliability. It is a huge liability if there are rolling blackouts or stuff of the sort. Additionally, they create efficiencies because they facilitate efficient electricity trading and product savings, as well as just fewer emissions because it is centralized and more efficient. So for the particular deal that I worked on, it was offloaded by another insurer. So it was already composed of this weighting predominantly in New York City, but it also has other densely compacted urban districts. So as you can see, New York City, Boston, Philadelphia, etc. But for the most part, they're in the Northeast. An important characteristic about this is that even though they're in different ISOs, they have generally the same weather. And so this balancing system really is an accurate way to adjust for the discrepancies. Furthermore, there is an off-season and an on-season to this problem, which causes a seasonality dichotomy. The on-season would be November 1st to March 31st, and the off-season will be April 1st to October 31st. And so the risk-on period is mostly winter, so you want to be able to calibrate for differences in weather over time. Furthermore, given the fact that we're working with a lot of historical data and the problem of climate change has been changing over time, it is important to compensate for this change as well as mitigate for abnormalities. Some years there may be a polar vortex or it may be unusually cold or hot. So you want to be able to mitigate for these fluctuations and have a stable baseline, as well as adjust for seasonality. So our solution to this was creating a heating degree index for the basket of goods. And what a heating degree index is essentially whenever there is a degree day below 65 degrees. So if it's 64, that's one heating degree day. And the great thing about this is this index could be calculated on a varying scale. It can be on a daily basis, monthly basis, or yearly basis, and so on. But for the sake of our experiment, we used a yearly basis. And this is evident that it has already been detrended due to the flat horizontal average over time. And this really optimizes historical data. But one of the biggest discrepancies that we came up with is that this is a relatively small sample size. There is approximately 60 samples, and that is not enough to create a reliable structure. So there is an in-house algorithm that was used to simulate more samples. And this is significant because we used over 5,000 samples, and as you can see, it is normally distributed. So this bell-shaped curve is really characteristic of how weather actually works. There is hotter days and colder days, but on average, there is an average temperature, and that's what makes weather easy to track and use in statistical computations. So now that you have the simulation, you want to find financial instruments that will accurately be able to compensate for the anomalies. And for the sake of our example, we used a plain vanilla swap, which essentially whenever the weather drops below a certain point, they get paid, as well as a simple vanilla put, which has similar characteristics, except the seller has an obligation to pay after the price drops below a certain point. And while we use very simple procedures, there are highly exotic option strategies that could be executed, and instances such as collars and straddle have a higher degree of complexity, but they could achieve similar goals. So for the swap criteria, it is a very simple structure. After it drops below a certain price, you simply take the difference and multiply it times the tick volume. And for confidentiality reasons, we chose not to show these, but essentially you got the strike, the tick, and a limit to protect downside. And the most significant statistical factors that are extracted from these computations is the fact that there is an expected value. After all those simulations, you will have an average of how much you get paid, as well as a shortfall, which is the worst case scenario for 1 percentile of the simulation. Additionally, the standard deviation is another important characteristic because it shows a larger percentage of what will actually happen. So you can take the shortfall price and the standard deviation price and multiply it times an individually mandated rate of return, and that will give you the premium that you seek in return for having these options. So this is the simulation of the swap payout. As you can see, it is almost normally distributed with a bit of a skew to the left, but this is because you want to have a favorable scenario where you get paid more than you lose due to the fact that you are an entity that makes money and you are mitigating the risk. So essentially, it is a win-win. Furthermore, there is a put strategy, and the formula is the same, except the client has the ability to execute whenever it drops below a certain rate. And once again, for confidentiality reasons, the specifics are blocked, but it works fundamentally the same. You're going to have the average payout on the basis of those 5,000 examples, as well as that very limited 1% shortfall and the standard deviation. And so once you get that shortfall price and the standard deviation price, you multiply it times your rate of return that you require, and that will give you the premium that you seek in exchange for this coverage. So this is a payout distribution, and as you can see, for the most part, you're paying less than 1.5 million, which is less than the premium, but you are often paying that limit. And if it weren't for the limit, then this would be even more skewed, but this limit is an essential characteristic for mitigating risk. And this gives a more holistic of what actually happens. So as you can see, approximately 20% of the time you're paying that 7.5 million, but approximately 15% of the time you're paying somewhere between 0 and 7.5 million. But here's the catch. For approximately 60% of the time, you're paying nothing out and collecting all the premium. And so it's simple statistics. You want to receive more money than you pay out. Therefore, this would be a very good way of executing this strategy. So throughout my time, I thought, what are the essential characteristics that you need to be able to execute these type of deals? Given the fact that they're very large deals, you would need a successive amount of equity capital. Additionally, you have to have sufficient credit to be able to remain solvent within credit crunches or things of the sort. If there are unforeseen events or bad deals that are executed, you don't want to be created obsolete through to some form of mistake. Additionally, you need vast resources in statistical computation and information access. Given that weather is normally distributed, but you want to have access to this information dating back, as well as ability to simulate more information to have a bigger sample size and more conviction of the product's significance. Additionally, financial derivative access is essential because you want to be able to capitalize on the shortcomings of weather's function. Finally, diversification is extremely important because you do not want to have highly correlated events in the instance that you have a bad deal. If you have 2 or 3 or 4 that are also very bad, this could create a problem with the solvency of a company because you will not have enough money to pay out these claims. Risk management is also an incredibly important characteristic of these strategies. Given that it is very statistically based, you want to have a vast amount of data to be able to compute the best scenario for your clients and your shareholders. Additionally, as stated, diversification is extremely important because you don't want to have highly correlated events in the instance of some shortfall. Using limits is an extremely reasonable approach to limit downside, as well as the ability to make money through a return requirement. Given the fact that there is some risk, you want to have a return requirement sufficient enough to make money when there's down years and up years. Finally, some assessment of volatility and risk, such as a P99 shortfall assessment, is innate because you want to be able to remain solvent when there is extremely bad scenarios, and this P99 is reflective of the worst 99 case scenarios. There is also the ability to apply this to so many more aspects of life and the economy. For our instance, we used temperature, but it can be applied to excess rainfall or insufficient rainfall, excess snow, excess cold or hot, insufficient wind, and insufficient sunlight. And I particularly like these last two because given the fact that we're making movements towards renewable energy and the wind doesn't always blow and the sun doesn't always shine, we want to have some kind of compensation for these events, and it's a perfect compromise between the two. Additionally, I worked on another deal that was based in Colombia where it was a hydroelectric producer, and basically they are extremely reliant on the amount of water that flows through that dam to create power. So there was a structure made where the less water there are, the more we pay them, but the vice is that so whenever there's more water, they have enough money to pay, and they pay for that protection. Additionally, I like to think of growth opportunities for this industry, and right now is mainly in power, but it can continue to grow in that. And that state of renewable energy, given its deficiencies, has an extreme potential in this industry. But something more creative would be travel and hospitality and the leisure industry. Given the fact that you could have a rooftop bar or recreational business such as Six Flags or other recreational events, these are highly dependent on good weather. So if there is too much rain or too cold, the revenues will significantly impacted. Therefore, to mitigate this, you could seek weather reinsurance to compensate for these shortcomings. So all in all, that was my experience with Munich Reinsurance, and I truly am so grateful for the opportunity to have participated in these very hard times. But I really had 3 main takeaways that I experienced, learned, and I'm going to take with me for the rest of my life. The first of which is the importance of risk mitigation. Given the fact that I had exposure to the risk department, credit department, legal department, and structuring department, I had a really well-rounded view of how a business functions and the importance of characteristics such as diversification, limiting downside, being able to assess VAR 99, the importance of credit, and so much more. And I know I'm going to apply these in my daily life, not only in my investing portfolio, but in my daily decision-making. I really want to have diversification and just be a well-rounded individual that doesn't have all his eggs in one basket. Additionally, given the fact that I'm in the TRIP program, I realized the power of finance, but not to the extent to which I realize now. Given the fact that I worked with 2 of the subsidiaries within Munich Re, which was MRTL, which was a weather business, as well as MRRF, which is a reserve-based lending business, it really draws a lot of parallels to how college works and the investing in your resources if it ultimately pays for itself in the long term, it is really a no-brainer to pursue it. Therefore, in the future, I will thoroughly think about the opportunity costs of my decision making and choose to invest more in things that I think have a net positive value and that will benefit not only myself, but my friends and my family. And finally, and most importantly, was what I learned about statistical analysis. I realized that much like how statistical analysis is in weather, it is really innate in so many aspects of our life and philosophy. Characteristics such as GPA, GDP, weather, and even your height to weight ratio is all fundamental in statistical analysis. Additionally, there are so many different kinds of distributions, such as a log normal, which is characterized as how oil wells are developed. They have increased production and extreme diminishing returns. Furthermore, there are Poisson distributions, which can help small businesses today realize where the main revenue is coming, what time, and how to limit expenses to have a more sustainable and logically based approach towards business. Additionally, these normal distributions are really seen everywhere, such as in the population of cities and even some so basic as rainfall. Additionally, linear regressions are growing in importance due to the basis of machine learning. Take a car's cylinder to power ratio, and for the most part, there is some sort of linear regression that could be associated with it. So going forward, I plan to continue to use my newfound skills in Excel, in R, in Python to develop new strategies and learn more about how the world functions around me. Furthermore, given the fact that I'm in the real estate business, I would like to develop my own algorithm that can take characteristics such as bed-bath ratio, as well as square footage and location to accurately price the price of a home, as well as using scrapping algorithms to automate processes and eliminate redundancies in my daily life. But there's truly so much I learned throughout my experience here, and I'm forever grateful. And I'd like to take those things I learned and complement them in other companies and continue to learn and continue to find value within daily life and processes that are done. But with that being said, that is all that I have to contribute today. I want to thank you so much for watching my presentation. If you have any questions whatsoever, don't hesitate to reach out to me at my email or in person. I'd love to get to know each and every one that watches this presentation, and I'd love to answer any and all questions. But that's all I have for today. Thanks. Gig 'em.